Hello and welcome guys. Welcome into Gaussian law applications part 1. Gauss law is a powerful tool for calculation of electric fields when they originated from a charge distribution of sufficient symmetry to apply it. If the charge distribution lacks sufficient symmetry for the application of Gauss law, then the field must be found by summing the point charge field of the individual charge elements. There are many applications of Gauss law, but in this chapter we will speak about point charge, uniform line charge, a charge isolated conductor, a uniform sheet of a charge, and a spherical symmetric charge distribution. To start with point charge, it is required to calculate the electric field at a point P due to single point charge. To find the electric field, it's required first to choose a closed Gaussian surface which encloses the charges passing through the point P. To illustrate the difficulties which can be encountered if we do not follow this general rule of selecting a surface to mirror the symmetry of the system, we will first choose a cube as a Gaussian surface. It can be seems that the integral will be extremely difficult to perform, as the flux line passing through the surface at a varying angles. For example, the angle between the surface vector and the electric field E changes. By looking at the symmetry of the system, we can select a sphere as the Gaussian surface. The electric field vectors are now always parallel to the surface vector, and therefore the electric field has the same magnitude over the complete sphere. Now, moving to the line charge. We can calculate the electric field created by infinitely long line of a charge at any point in the space by using the cylindrical Gaussian surface. The net charge enclosed by the surface equal to lambda times L. The electric field lines are parallel to the surface vectors around the surface of the cylinder, and perpendicular to the surface vectors of the top and the bottom. Performing the integral of each surface, we will get that Q over epsilon 0 will be equal to E times 2 pi times L times R. So the electric field E will be equal to K times lambda over R, where R is the radius of the cylindrical surface. This is the end of the video guys. I hope that you enjoy it and get benefits. Please don't leave this video without a like, a comment if you have any question, and a share. Also, if you don't subscribe yet, do it now to get more interesting topics in the future.